So, ladies and gentlemen, when we're looking, so what basically on this question, what I'm asking you guys to do is solve. I want you to solve for your quadratic. All right, I want to solve the quadratic. Now, when we're looking into solving the quadratic, you could graph this. And we have shown how to graph it in standard form, shown how to graph it in vertex form. You can graph it, and then I'd see where they cross the x-intercepts. However, algebraically, we can identify where those points were. Remember I made those points on where it crossed? We can algebraically determine where those points are. So to do that, we understood that the first thing, that the y value is equal to 0. So if you have y or f of x, either way, the first step is to set it equal to 0. OK? So I saw some students on their homework quizzes, they left their thing blank. They didn't know how to do the problem. The first step you guys should always know how to do is set it equal to 0. OK? That's just an understanding of what we're trying to do when we're trying to find the solutions.
When we're doing quadratics, the y is always equal to 0?
When you're solving for your quadratic, meaning we're trying to identify the x-intercepts, you're going to set your y coordinate equal to 0. Or the y value equals 0.
On that next, you're going to subtract 16 by both sides?
OK. So now what I want you guys to understand is when we look at this, this value, how many x's are in this equation? 1, but it's an x squared, though, right? But there is only one term, x. So we can solve this just like a linear equation. Same thing. There's only one term that is x. So you can solve it just like this. Just like a linear equation. But we're going to solve it with x squared, though. Could you solve this?
No, what happened to the x?
Yeah, I'm not changing the problem.
Oh, okay.
This is like, I'm just saying,
Oh, okay.
if I gave you this, could you guys solve that?
Yeah.
OK. You're going to do the same thing over here. Since there's only one term, subtract 16, just like Jason asked, equals 2x squared. Then you're going to divide by 2. And you have negative 8 equals x squared. Now, to undo squaring. Now, we need to undo the squaring function. So undoing squaring, we need to take what we call the square root. And what the square root says is what number multiplied by itself gives us negative 8. Well, ladies and gentlemen, there's no number that multiplies by itself to give us negative 8. So whenever you try taking the square root of a negative number to find the x-intercepts, you can just write no solution. OK? You actually are going to have intercepts. They're going to be imaginary, but that's going to be later in this course. Yes?
So with these, we're going to have to put like the plus or minus.
Yeah, we're going to do a plus or minus. I'm going to do another problem. You know, if you're trying to take the square root of a negative number, we will do plus or minus. But that's once we get into the complex number system, which we're not on yet. So right now, you can just say, hey, if I'm taking the square root of a negative number, that means this graph does not cross the x-axis. So therefore, it's no solution. Yes?
If it's a negative.
Hold on. Yes.
So if it's negative, you just want us to put no solution?
Correct. For right now, yes. Yes. Till the end of this chapter, once we learn our imaginary number system. It'll make sense to you later.
So no matter what it's a negative number, is no solution automatically?
Well, think about it this way. Instead of no solution, just write no x-intercept, right? It does not cross the x-axis.
No solution is quicker.
OK.
So every time you can't find the square root of no solution?
Yes.
Also, when it's like negative 4,
It doesn't.